In this video, we're going to look at how to solve some other applications of using sine, cosine, and tangent to solve for the missing angles and sides in a triangle, other than the ones dealing with angles of elevation and angles of depression. First, we'll look at some different systems for measuring angles of rotation. These are generally used for any type of navigation question. You will most frequently see the term bearing used for these, although they may have a different term like the course that they're headed in. So the first and probably most common method of measuring a bearing is just to give a single angle measurement. And this is similar to what we've been doing with the angles in the unit circle, but instead of starting at east and rotating counterclockwise, these start from north and they measure the clockwise rotation. So for a couple quick examples, if we have an x and a y axis here, 90 degrees means starting from up and then rotating to the right 90 degrees. So it would actually be pointing straight to the right in this case. For another example, we have 210. So if they say a bearing, again, make sure you start from north and then rotate that measurement going around clockwise. So this would be 90 degrees, 180 degrees, and then 210 would go a little bit farther in this direction. So that would leave a 30-degree angle in here. A second method for measuring your bearings is to have three different parts to the number. First, this part is always either going to be north or south to indicate whether the arrows need to be going up or down. Then we have the angle that's being made with that north or south direction, followed by whether it's going to the right or to the left of that vertical line. So for this one right here, for example, if I have my x and y axis drawn, this one is saying I'm going to be going north and east, so I know it's going up and right. And then the angle measurement is measuring that this angle in between the vertical line and our diagonal line is equal to 20 degrees. So for a second quick example, this one again has three parts. This time I'm going south, so I know it's going down in some direction, and west, so I know it's going to be on this side of the vertical line. So I'm going south and west, and the angle is telling me that in between the vertical line and the diagonal line is equal to 50. So we do have to be able to use that information to create triangles. We do have to be very precise about where those angle measurements are going, especially the angles that are made with your x and y axis. Then we'll combine that information with whatever else has been given to us in the question, usually something like a speed. So our sides will usually be the distance, not the speed of the object. And then that'll give us the sides of the triangle, which then we can use SOHCAHTOA or Pythagorean theorem to find missing values. A couple other geometry rules that will be helpful in tackling these questions. You should be familiar with the angles in a triangle adding up to 180 degrees. That's a pretty common one. And then we have angles in a linear pair. So if you have two different angles, like this angle and this angle, but they combine to make a straight line, that's what I'm referring to when I say a linear pair, then those two angles have to add up to 180. So something like 30 and 150, for example. Also, if you know two sides of a right triangle, make sure you're only doing this for a right triangle. Remember, you can find the third using Pythagorean theorem. And many of our triangles, since we're dealing with navigation questions for some of these, our triangle is almost always going to be the distance the object has traveled, not the speed. So usually you need to take the speed and the time and multiply those numbers together, and that will be the side of your triangle, the rate times the time to give you the distance. First, we have a construction problem, so we don't need to worry about bearings on this one. We have a larger triangle, and we have two smaller triangles within that one that combine together to make the bigger shape of the roof. Now, one important thing to notice on this one, since we have 15 degrees for both of these, and they are sharing this common side, that means that we actually have two similar triangles here, and it won't always be this easy, but in a case like this where the angles do match, that means we can just split this length in half. So this length of 76, we can actually break this down and look at one triangle on either side, it doesn't matter which one, of 38. The advantage to doing this is now we have a right triangle, so we can use rules like SOHCAHTOA and our Pythagorean theorem information on it. So after recognizing we can split this big triangle into one small triangle and find the height here, and that'll be the same answer as the vertical center span of the entire roof, now we want to pick a trig function that'll relate the opposite side and the adjacent side to our angle. So in this case, I'm going to be using tangent of 15 degrees. And then that will equal our height that we're looking for, divided by the adjacent side, the base of our triangle, of 38. And then if we multiply both sides of the triangle by 38, we should get, rounded to the nearest tenth, approximately 10.2. So do keep in mind that this will be a little bit more complicated if the angles were not the same, because then we could not just split this length in half. We'll deal with questions like that in a later section. Now for our first question dealing with a bearing or a heading for navigation purposes. So I'm going to break this into two parts. First, I'm focusing on the first part of his trip, the part before he makes a turn and changes course. So for right now, I'm just focusing on a ship traveling at 30 knots from his home port on a course of 123 degrees. Now remember that the bearing is starting from north and rotating clockwise. So the angle from north down to here is 123. But we're generally more concerned with the angle that we make with the x or the y axis. So I subtracted the 90 part from this that we didn't care about to find that this angle in here was 33. The other important piece of information is that they say he's traveling at 30 knots. Well, this is just a speed for traveling over bodies of water, just like miles an hour. So he's traveling at 30 knots for 1.5 hours. So again, in this case, we want to do our distance equals rate times time. So we would have 30 times 1.5. Because on the triangle, we actually want the distances that are getting covered here. So 30 times 1.5 is 45. So right now we have both an angle and a length for creating our triangle in a moment. Every time a direction or bearing is given to you, or if there's like a turn in the trip, I always recommend drawing a new x and y axis, because then we need to recalculate our bearing from that location. So the ship started here at an angle of, or a bearing of 123 degrees, moved down to this point, and now he's going to turn. So we want to again calculate what direction he's turning in, and the angle this time they gave us was 213. So starting from north, that would be 90, 180, and then a little bit more in this direction means that now I know he's heading southwest from there. To actually put some numbers on our triangle, one thing that's nice to note here is that the difference between 213 and 123 is 90. So if I imagined a straight line coming out of that, that means I have a right angle here, which means I also have a right angle in here. So that's what's going to create the right triangle piece for us. Now we have a 90-degree difference between our 123 and our 213. So after the ship travels along this direction for a while, we're going to be comparing that final position to his original starting position. So our third side of the triangle will just be saying from the port all the way to where he ended at. Now we also should be able to fill in this side of the triangle by again using the distance equals rate times time. He changed direction, but he did not change speed. So we're still going to be using a rate of 30 knots. But he traveled for a longer time in this direction. At this bearing, he was traveling for 2 hours. So now we're going to do 30 times 2 to get a distance of 60 on the triangle. Now looking at our question, we need to do two things. First, we need to find the distance from the home port to the ship. That can be found using Pythagorean theorem with our sides of 45 squared plus 60 squared. And if you just type these into the calculator and take the square root, the answer to the missing side should be 75. So that's one part of the question. Now we know that we are 75 nautical miles away from the port at the end of our trip. And then the last piece we need to do is find the bearing. And so this is again going back to the port, which we started off with up here at the very beginning. So we need to find what angle of rotation is being described from due north all the way down to this line here. To do this, we can use our trig functions. We can use our inverse trig functions specifically. I always recommend using the sides that you were given when you're picking which trig function to use instead of any sides that you found using Pythagorean theorem, because then you have to start worrying about any rounding that you might have done to find that third side. So from this angle in this corner, I'm going to use tangent. So I'm going to take tangent inverse, because that'll give me the opposite side divided by the adjacent side. And making sure you're in degree mode on your calculator, this would be 53.1 degrees. But then that's not our final answer actually, because remember that was the answer we just found for what's inside the triangle. That's what the inverse trig functions do. But we need to combine this entire amount of rotation starting from due north around to that line. So if inside the triangle is 53.1, then we need to add that number to the original 123 we had from the question over here. So 123 plus 53.1. And honestly, a lot of the degree questions usually have you do the angle to the nearest whole number. So always pay attention to the directions on that. But this should give us a bearing of 176.1 degrees. So from the port, we now know the distance and the bearing. And finally, let's get a word problem using the other form of bearing. So we have two different rangers, and I've decided to label them as Ranger A and Ranger B. And to describe the position between these two rangers, they say that the second ranger is 10 miles east, so straight east from the first one. So I have a distance of 10 between these points. Now, the first forest ranger sighted a fire directly to the south. So if I made a bearing from him, that would have been going straight south down in this direction. And the second ranger also sights the fire, but the direction for him is going southwest. So from this position, we're going down and to the left. And the angle that they've given us here, remember this angle is describing what's made with the vertical line. So I know that inside here is 22 degrees. Which may make it more helpful to find the angle inside the triangle. So if you do 90 minus 22, then we know that this angle here is 68. It's also helpful to recognize that since we had straight east and straight south, then that means we do have a right triangle, which is what's going to let us use Pythagorean theorem in SOHCAHTOA. So now, since they're interested in the distance from the first ranger to the fire, that means we're looking for this opposite side from our given angle here. So we need to pick a trig function that uses the opposite and the adjacent side. It is very commonly tangent when you're doing these. So here I'm going to have tangent of 68 degrees. And set it equal to opposite over adjacent. So if you multiply both sides of the equation by 10, make sure you're still in degree mode, you should get a distance of approximately 24.75. Again, what you're rounding to will vary from question to question. Just always look at the directions that are given on a specific problem. They could have asked us for the distance from the second ranger as well, in which case we could have done Pythagorean theorem, or we could have just chosen a different trig function to use SOHCAHTOA on for finding that missing side. And that's it for this lesson. So if you like the video, be sure to hit like, subscribe, or comment.